Micro-irrigation is the slow application of continuous drips, bubbler, subsurface, or sprays of water above or below the soil surface. This system is most suitable for water-scarce areas and in hilly terrains where ground is uneven and undulating. Unlike traditional methods that often result in water wastage, each micro-irrigation systems prioritize precision and efficiency, delivering water directly to plant root. This concise introduction explores the fundamental principles, key components, and overarching benefits of micro-irrigation, showcasing its pivotal role in sustainable agriculture. In this presentation video, we can get a brief idea about micro-irrigation. Micro-irrigation is a water-efficient method of irrigating crops by delivering water directly to the root zone. It minimizes water wastage and promotes efficient water use. There are main two types in micro-irrigation systems. They are the drip irrigation systems and the sprinkler irrigation systems. Drip irrigation is the most efficient water and nutrient delivery system for growing crops. It delivers water and nutrients directly to the plant's root zone in the right amounts at the right time, so each plant gets exactly what it needs when it needs it to grow. Involves the slow application of water directly to the root zone through a network of pipes, tubes, and emitters. Emitters control the flow rate, providing a precise amount of water to each plant, suitable for a wide range of crops, especially those with precise water requirements. Now you can see advantages of the drip irrigation systems. Up to 50% of water can be saved. Fertigation via drip is over 30% more efficient than via flooding. The combination of drip irrigation and fertigation increases productivity by up to 200%, and in sugarcane by up to 133%. Sprinkler spray irrigation is the method of applying water to a controlled manner in that is similar to rainfall. The water is distributed through a network that may consist of pumps, valves, pipes, and sprinklers. Irrigation sprinklers can be used for residential, industrial, and agricultural usage. Utilize a system of pipes and pumps to distribute water in the form of droplets, simulating natural rainfall. Various types of sprinklers are used, such as fixed, rotating, or oscillating, depending on the crop and field layout, suitable for a variety of crops and adaptable to different soil types. Sprinkler devices and sprinkler systems are available in many varieties. There are many different types, sizes, prices, and capabilities of sprinkler irrigation systems. These are some advantages of sprinkler irrigation systems. One, it is suitable for virtually all types of soils with infiltration rates less than 4 cm. 2, the sprinkler irrigation system is suitable for the irrigation of almost any crop. 3, suitable for irrigating uneven terrain. There is no need for land leveling. 4, irrigation water can be utilized to apply fertilizers, herbicides, and fungicides. These are several disadvantages of sprinkler irrigation systems. 1, causes sprinkler patterns to be distorted and cause uneven distribution. 2, soft fruit that is ripening must be protected from the sprinkler spray. 3, high initial installation cost. 4, this system operates at 5 EM to 100 M of water head, so it requires a great amount of power. 5, sprinkler irrigation system is not suitable for fine textured soils with slow infiltration. 6, The movement of portable pipes in certain soils after irrigation may pose a problem. 6. The movement of portable pipes in certain soils after irrigation may pose a problem. The choice between drip and sprinkler irrigation depends on factors like crop type, field size, and water availability. Micro-irrigation systems can be arranged in several ways. For a system to irrigate satisfactorily, the application of water must be uniform. There should be no more than a 10% variation in discharge between the emitters with the lowest and highest output. To achieve this, pipes and tubing must be sized correctly. At the water source, water is controlled with automatic valves, sometimes amended with nutrients or chemicals, filtered and regulated at levels suitable for the emitters. From there, water is delivered to each emitter through a network of polyvinyl chloride, PVC, and polyethylene pipes. Pumping station, types of groundwater pumps, pump curves, variable frequency drives, WE, electric motors, internal combustion engines, filtration systems, water flow meters, pressure gauges, and emitters are some of categories in the components of a micro-irrigation system can be grouped. Design considerations of micro-irrigation systems are the factors that affect the performance, effectiveness, and felicity of the system for a given point, crop, and water source. Some of the crucial design considerations are the water demand and irrigation scheduling of the crop, grounded on the original climate, soil, and factory characteristics. To when tribe and layout of the micro-irrigation system, similar as drip, spray, bubbler, or subsurface, and the distance and placement of the emitters, sprinklers, or drip lines. The water quality and vacuity, and the need for filtration, pressure regulation, and chemical treatment to help clogging, erosion, or impurity of the system. The hydraulic performance and uniformity of the system, and the relationship between the discharge and pressure at the pump, the main line, and the side line. The installation and conservation costs and procedures, and the continuity and trustability of the system components. The installation process. How your garden, add to your planting areas, noting plant types, water needs, and sunlight exposure. This will help determine the type and layout of your irrigation system. Select a pressure regulator, timer, main supply line, distribution lines, emitters, and connectors based on your garden size and water pressure. Draw a system layout. Plan the main line route and branch connections to reach all plants, or mark emitter placement for each plant. Refer to your main shutoff valve and turn off the water to your hose bib. Attach the pressure regulator and timer. Screw the pressure regulator onto the hose bib, followed by the timer. Run the main supply line. Lay the main line tubing along your planned route, enough to stakes or ground staples to secure it. Install branch lines and emitters. Connect branch lines to the main line using couplers or tees. Punch holes in the branch lines where needed and insert emitters, drippers, micro sprays, etc. Low flow irrigation systems, deficit irrigation, groundwater recharge estimation, and irrigation in viticulture are some of cases we have to think. Smart irrigation controllers text, soil moisture sensors, the use of robotics in micro-irrigation, and artificial intelligence for decision-making and irrigation scheduling. These points are very useful for micro-irrigation systems.